Let's learn how to trace for loops in Visual Basic, showing scratch work the way Mr. Minnick likes it. Here we have a variable sum. It's initialized to 0. Been there, done that, check. We have a for loop, j, the loop variable it's called. J starts at 1. Eventually it'll hit 3, but let's see how it gets there. J starts at 1. We already recorded that as well. We now enter the body of the loop and we execute this assignment statement. We all know that assignment statements work from right to left. So execute or evaluate the expression on the right. Sum plus 1. 0 plus 1, that adds up to 1. And where does the 1 go? It gets plugged into the variable on the left-hand side, which coincidentally is also sum. Crossing that out with a single slash, Minnick style, and putting a 1 there is just good scratch work. We hit the word next, which means to loop back up to the top of that for loop. That's what a for loop does after all. It loops over and over again. It iterates over and over again. And now we're ready for the second go around. The second time around here, oh, I forgot. J increments by 1. So J now bumps up to 2 the second time around the for loop. Okay, so now we go through the for loop again. We evaluate the right-hand side, which says to add up sum plus 1. Well, sum is currently 1, so plugging that in there, we have a 1 plus a 1, which simplifies to 2. And where does that 2 go? It goes into the left-hand value there, which happens to be sum. Coincidentally, that 1 crosses out and now becomes a 2. Okay, we're done with that iteration. We're almost finished. We hit the word next, which means go back up to the top of the Ferris wheel, getting ready to come down again. And J bumps up by 1 because the default step amount in VB is always to step by 1. You don't have to type it out, but you could if you really wanted to. So we stepped by 1, J is up to 3, and because J is equal to 3, we do go through the loop one more time. In which case, sum plus 1 simplifies to 3, because this 2 plus 1 is 3. The 3 plugs into sum. Cross out the correct number over here on your scratch work. Don't get sloppy. And now the computer's dumb. It loops back up to the top again. It still steps 1 on the loop variable J. So you still have to make this 4. But then it realizes, whoa, 4 is greater than my upper boundary of 3 in this for loop here. So do not go through the loop again. You do not execute this line of code. And then if there was anything left in the program down here, you would execute it. We are now done, finished, iterating this for loop. And the final value stored in sum is 3. Just for the record, the final value stored in J is 4. If you were to print out J anywhere else in this program, a side effect here is that it's 4. A lot of beginners think, oh, J goes up to 3. No, it goes up to 4, idiot. So make sure that you know your programming and know that J is really 1 higher than the boundary there. Usually we don't use J for any other purposes in the program, so that doesn't cause a problem. But just be wary that Minnick will take a ½ point off on this worksheet if you had circled a 3 instead of a 4 there. And I do always want you to circle your final values. Another curious part of this whole exercise. We just used a loop to add up 1 plus 1 plus 1, because that's what this loop did. Think about it. We're iterating 3 times, and we're adding $1 each time around. So $1 plus $1 plus $1 is 3, and that's what our final value for sum was. Later on, you'll see that sometimes on this worksheet, I might have 5 here. Well, the final value of sum would be 5 in that case. If we change this 1 to a 2, and we reverted back to the original 3, think about it. You're just adding up 3 $2 bills. You're just adding up 2 3 times. There are a lot of patterns that smart people can use to get ahead of the less smart people. So just think about it, but when in doubt, be sure to trace the loop carefully, showing good scratch work. This technique has worked for hundreds of students before you, so don't let us down now, and do not copy answers from other people, because I often give different worksheets out to the same class where I change like a 5 to like a 4. And the guy next to you has that version of the worksheet. And if you just look at his circled answers, I know who the cheaters are. and both worksheets say worksheet number 1. I just have a secret way of knowing which worksheet is which. So good luck in tracing this worksheet. The only other tricky aspect of this is that in some of these questions we go step 2 instead of step 1. And oh, look at that, step -1. So J doesn't always go up by 1s like it did here. Just be careful with that. Thank you, and have a good day. Okay, folks, let's learn how to trace for loops in Visual Basic. Here's a worksheet where we have an exercise that has a for loop in it. The variable sum is being declared as an integer set equal to 0, and I've already done that one for you. I've already put a 0 there under that column. Next, we hit the for loop for the first time, and this variable j is equal to 1. Oh, I've already reflected that, so there's already a 1 there where there needs to be. The loop then executes the body of the for loop, so the statement sum equals sum plus 1 executes. And that statement causes the right-hand side to evaluate. Well, sum is currently 0, and therefore 0 plus 1 is equal to 1. And where does that 1 go? It gets plugged into sum. So you simply cross out the 0, and you put a 1 underneath it neatly. I recommend writing small and neat because sometimes these columns get really long, and your paper ends up being messy if you don't write small. Okay, so a 1 got plugged in there. Then the computer hits the line of code next, which simply means to go back up to the top of the for loop for its next iteration. Each time a for loop goes around, it's called an iteration. Okay, well, the second time around the for loop, j is 2. Get it? 1, 2, 3. That's how j works in a for loop. So j, we have to cross that out and make it a 2. Now the computer goes through the body of the for loop again, and so we execute this line of code again, sum equals sum plus 1. But this time, sum, here on the right-hand side where we always start, sum is currently equal to 1. So plug that 1 in there, and when you simplify 1 plus 1, you get the magic answer 2. And you ask, where does that 2 go? It goes into the variable sum, thus overwriting the old value of a 1. So you have a 2 there now. You should use a pencil for this kind of worksheet because sometimes you mess up and you need to fix things. Anyway, you now hit the line of code next, which means you go back up to the top, and you step j up 1 more. So j is now up to 3. Reflect that, please, on your scratch work by crossing that 2 out and making it a 3. And you proceed through the loop again, erasing any scratch work that you had in there before if you can't do this stuff in your head. And I recommend writing these out. As a beginner, I do recommend that you use your pencil and write things on your paper. Anyway, we're now executing the line of code sum equals sum plus 1, but sum is currently equal to 2. So plugging your 2 in there, 2 plus 1 is 3, and you ask, where does that 3 go? It goes into the variable sum. Cross out that 2 with a single slash, put a 3 under it. Don't mess things up like that. Always use single slashes. It helps you retrace your work if you ever make a mistake more easily. Well, anyway, we hit the word next again, and we do go back up to the top. J does step up 1 more to the value 4, but it realizes, hey, I'm now over the upper boundary, and therefore I'm not allowed to go through the for loop anymore. So please do cross out that 3 for J and make it a 4, and that's where this exercise ends. The pattern that you see here is that in a problem where it's j is being used as the loop variable, j ends up being 1 higher, 1 number greater than the upper boundary that's typed into the problem. So please circle that 4 and circle the 3 under sum, because on this worksheet I stress that you should circle your final values for full credit. Other patterns that you should recognize. The number of loop iterations here, it's the formula high minus low plus 1, which means high is your upper boundary 3, low is considered to be your lower boundary 1, and you always add 1 because of the fence post phenomena, and 3 minus 1 plus 1 simplifies to 3, and that's how many loop iterations we just saw in this example. There were 3 loop iterations. Well, what a coincidence. We looped 3 times adding 1. like a dollar bill. So if somebody gives you a dollar bill 3 times, like 3 times around the merry-go-round, the ticket taker guy gives you $1, you end up with $3. It's a nice little pattern here in this problem. If this were a 5 in the original problem, you could have guessed that the final answer here for sum would have been 5. It's pretty easy. Okay, let's do the next problem in this worksheet. Sum is initialized to 0, okay, and J, okay, in this case, J starts at 11. I've already reflected that with that 11 there, and now sum plus equals 1. Well, this is just the lazy programmer's way of writing the same thing that we did up here with sum equals sum plus 1. Sum plus equals 1 still adds whatever to the variable sum. So that 0 changes to a 1. We hit the word next, which means we loop back up to the top, and we step J up to 12. So J is now 12. And we add 1 to sum because we're going through the loop again. So sum is up to 2. J and sum have nothing to do with each other, by the way. Sometimes J starts at 11, sometimes it starts at 111. It really doesn't affect what sum is in this case. Anyway, we just added 1 to sum. That was nice. So we hit the word next, which means we loop up to the top. J now bumps up to 13. It always goes by ones. And because we are at the number 13, we do go through the loop again. So sum plus equals 1 causes us to add 1 here to this 2 to make it a 3. We hit the word next, which means go back up to the top. And J bumps up to 14. But at that point, it realizes, hey, 14 is above the upper boundary. So we do not go through the loop again. We just kind of end. This part of your program just ends. The final result is that J hits 14. Circle that, please. And the sum ended up hitting 3. Really, this exercise number 2 is the same darn thing as exercise 1. We just added 1 to itself 3 times for a grand total of sum equals 3 in both exercises. The fact that J went from 1 to 3 here and that it went from 11 to 13 really doesn't matter. What happens to J isn't really a main concern to a programmer when they trace for loops. Let's do number 3 together. In number 3, sum starts at 0, okay? J starts at 1, okay? And then sum plus equals 1 executes. Okay, so we cross this 0 out, make it a 1. We hit the word next, which everybody in this room knows that we loop back up to the top of the for loop. But in this problem, instead of stepping by 1 for J, we step by 2 because it says so. You see, when the word step isn't written out, the default is for a programmer to step by 1. So pretend that step 1 is typed out in any for loop that you see. If there's nothing there, just assume it's a step 1. But sometimes programmers have a reason to go by 2s. So the second time around the for loop here in exercise 3, J bumps up to 3 because that's what 2 added to 1 is. 1 plus 2 is 3. Okay, well anyway, we add 1 to sum. So sum is now 2. We hit the word next, which means go back up to the top. And we step by 2. So J goes up to 5. Now you do have to ask the question, are you supposed to go through the loop again or not? Yes, if J is equal to this upper boundary, you do go through the loop one more time. So we do execute the line of code sum plus equals 1. So yet again, sum bumps up to 3. And we hit the word next, which means we go to the top again. And just for the record, J does end up at 7. It still steps by 2 more, and then it realizes, hey, when I'm 7, I'm bigger than this number 5, and therefore I don't go through the loop again. So that's where this exercise ends. Please circle on your answer area, 7 is the final value of J, and more importantly, sum is equal to 3. I reserve the right to take off points if you circle the 5 here, and if you were to have circled the 13 back here. That's technically wrong, because in each of these questions, even though the upper boundary of J is 13 and 5, j goes one step higher than those upper boundaries. It's dangerous if you're a programmer and you don't realize that, because it could cause problems later on in your program if you use j. Typically, it's not a big problem, so I only take a half point off. The real important variable here on this worksheet is the variable sum. Okay, I will leave number 4 for you to do as an exercise, but do notice that instead of going up by 1 each time, you're stepping -1. You know what, I'll do it for you anyway. J starts at 3, okay, we acknowledge that, and sum starts at 0. Okay, well, sum plus equals 1. We add 1 to sum, we hit the word next, we step j by -1, so j goes down to 2. We ask, is j less than 1 yet? Nope, it's not, so we go through the loop again. So sum goes up to 2. And then we go to the top of the loop where we step -1. So j bumps down to 1. Now in this case, because we're stepping by a negative amount, the question to ask is j less than this boundary here? Well, no, it's not. It's equal to it. 1 is equal to 1. So we do go through the loop yet one more time. Sum plus equals 1. Okay, cross that 2 out, make it a 3. Hit the word next, which means go to the top. And we do step -1 again. So j goes down to 0. And now you ask that important question, is j less than 1? Yes, it is. So you're done. That's just how you end what I would call a backwards for loop, one that has a step negative. So circle on your answer sheet 3 and 0 for that problem. Okay, one more to do for this worksheet. Number 5, sum begins at 0. J begins at 1. Oh, sum plus equals 2. Okay, sum goes up by 2 this time. And all the other questions before it, sum just did a +1. Here it's a +2. Oh well. We hit the word next, which means we go to the top of the for loop. J steps by 1 because the word step 1 is implied as the step amount. So j bumps up by 1. And we go through the loop, sum plus equals 2. So sum is now 4. And we hit the word next, go to the top. J bumps up to 3. And we do go through the loop again because j is equal to its upper boundary. So sum plus equals 2 executes for a grand total of 6 now under sum. We hit the word next, we go to the top. J does bump up to 4, but then it realizes, whoa, stop. 4 is greater than 3. I'm out of bounds. So I don't go through the loop anymore. Therefore, sum has its final value of 6. So there are your answers for number 5. You can do number 6 on your own. And number 7, that's that formula that we went over earlier in the class period. It's in my notes. It's the formula that relates to the fence post phenomenon. Hey, how many pages are you reading? If you read between pages 6 to 10, you're really reading 5 pages. Page 6, 7, 8, 9, and 10. Not just 6 through 10, but 6 through and including 10. So that formula should be written out there. And number 8, high minus low plus 1. Oh, I just gave it away. Well, high minus low plus 1, 10 minus 1, plus 1. Final answer is 10 for this question. You can do number 9 on your own.
The afternoon announcement.